Hello all, welcome to the course on Python programming for beginners. We are in Module 11, Object-Oriented Programming, Lecture 6. In this lecture, we are going to discuss about the polymorphism, which is one of the main features of object-oriented programming. Now first, let us look at the meaning of polymorphism. Polymorphism is taken from the Greek words poly, which means many, and morphism, which means different forms. So in Python, we have different ways to define polymorphism. We can achieve polymorphism using operators, using class methods, and also using inheritance. Consider an example where there are two variables, number 1 and number 2, which are initialized to the values 1 and 2. And if we perform num1 plus num2, it is going to perform the arithmetic addition. So the result is 3. Consider another example where there are two string variables, str1, which is initialized to Python, and str2, which is initialized to programming. Now, if we try to perform str1 plus str2, in this case, the Python programming is being concatenated. That means the two strings are concatenated. So in the first example, it is performing arithmetic addition, which is used by the plus operator. And in this case, where there are strings, it is performing the concatenation operation. So depending on the type of the operands, the meaning of the operator is being changed. So here we can see that a single operator plus has been used to carry out different operations for distinct data types. That means for numeric data type, it is performing addition, and for string data type, it is performing concatenation. So plus is implemented in two different forms. So that is why it is an example of polymorphism with operators. Now let us look at another way of implementing polymorphism using class methods. Now let us observe the definition of two classes here. Class India, where there are two methods, capital and language, and the capital method is defined using define capital, self, print New Delhi. We are just printing the capital of the country. And there is another method, define language, where we are printing the language of the country. So print Hindi and English. Let us also look at the definition of another class, USA. Define capital, self, and we are printing Washington DC. And define language, self, and we are printing English here. So here, India is a class in which two methods, capital and language, are being defined. And USA is another class in which the same methods are defined once again. That means two different classes are using the same set of methods. Now let us see. Obj underscore int is an object of India class. We are creating obj underscore int, which is an object of India class. And similarly, obj underscore USA is an object of USA class. Now, if we invoke the methods capital and language on obj underscore int and also on obj underscore USA. So in the first case, it is going to invoke the method that is being defined in India class, because obj underscore int is an object of India class. So it is going to invoke the capital method, which is defined in the India class. And similarly, obj underscore USA dot capital, it is going to invoke the capital method which is defined in the USA class. That is why we have New Delhi and Washington DC. And similarly, obj underscore int dot language, it is going to invoke the method which is defined in the India class, because obj underscore int is an object of India class. And similarly, obj underscore ESA language, it is going to invoke the method of the class ESA. So though we have the same method names in both the classes, depending on the type of object, it is going to invoke the corresponding method. Obj underscore int is going to invoke the methods of the India class because it is an object of India class. So in this we can observe that depending on the type of object that is being used, the corresponding method of that class is being invoked. So here we can observe the same method having different meanings in different classes. So this is an example of polymorphism with class methods. Now let us understand polymorphism with inheritance. So in inheritance, we already know that all members available in the parent class are by default available in the child class. So whatever the attributes and methods that are available in the parent class are also inherited to the child class. If the child class does not satisfy with the parent class implementation, then the child class is allowed to redefine that method. So by default, all the members will be inherited, and if the child class is not satisfied with the inherited method from the parent, it can redefine its own method. So this concept is called as method overriding. So an overridden method in the child class has the same name, same parameters, and also the same return type as that of the method in the superclass. Then only we say that it is overridden. So whatever the method that is available in the parent class, it has a different definition or different implementation in the child class. But the name of the method, the return type, and the parameters, number and type of parameters will be the same in both the parent class as well as in the child class. Let us consider an example. Class vehicle. Here we are defining max underscore speed, where we are printing max speed is 100 kilometers per hour. Now let us define a child class car which is inherited from vehicle. So in this we have an overridden implementation of max underscore speed. So max underscore speed is already defined in the base class, which is by default is also part of the child class car. But again, the car class is defining its own version of the max underscore speed method. So here also we are printing max speed is equal to 200 kilometers per hour. So when we create an object of car class, that means the child class, car equal to car dot max underscore speed. So it is going to invoke the method of the child class because it is being overridden in the child class. So this is how the order of invocation of the method will be. If it is found in the child class, it invokes the method from the child class. If it is not found, that means the method is not overridden in the child class. In such a case, it invokes the method of the parent class. So let us understand about the method resolution order. So in Python, method resolution order is the order by which Python looks for a method or attribute. That means when we implement some hybrid inheritance, MRO defines the order of searching for the methods that are being overridden in the child class. So the order is like this. First, the method or attribute is searched within a class, and then it follows the order we specified while inheriting. First is it searches in the child class. If it is not found in the child class, then the order of inheritance is followed. This order is also called as the linearization of a class, and the set of rules that are used for invoking the method in the inheritance is called as method resolution order. So MRO plays an important role in multiple inheritances, as a single method may be found in multiple parent classes. In multiple inheritance, the following search order is used. First, it searches in the current parent class. If it is not available, then it searches in the parent class specified while inheriting. Again, the order is from left to right. We can get the MRO of a class by using the method MRO. Now let us understand about the MRO in detail using an example. Here we are defining a class A in which there is a method define process print in class A. And we are defining another class B which is inherited from A, and we are overriding the method process. Already process is inherited, but if we want to change its implementation, then we have to redefine the process in the child class. So here we are overriding the method process. And here also we are printing in class B. Next we have another class definition, which is class C, which is inherited from both B and A. And the order of inheritance is B followed by A. Here also we are overriding the method process with a different implementation. So we are printing in class C. Now we are creating an object of the child class C by using C1 equal to C. Then we are invoking the method process by using the object C1, C1 dot process. So if we look at the order of invoking the methods, first it will search in the current class. What is the current class? Current class is C, because C1 is an object of the class C. So it searches in class C. If it is not found, if the method is not found in class C, then only it will search in the classes B, then it searches in class A. So that you can observe in the output. So in the output, it will give what is the order of invoking the methods. Let us consider another example problem where we have three different classes X, Y, and Z. A is inherited from X and Y, B is inherited from Y and Z, and M is inherited from the classes A, B, and Z. An object is the superclass of all the classes in Python. So object is a predefined superclass of all the classes in Python. Now, if we want to display the method resolution order of class M, it is going to first search in class M, then it searches in class B, followed by class A and class Z. So it has to search in class B first, then it has to search in class A, and then since class A is also class A is inherited from X and Y, and class B is inherited from Y and Z. So first of all, it searches in the class M. If it is not found, then it searches as per the order of inheritance. So it searches in class B, then class A, then again it searches in class X and class Y, followed by class Z, because A is inherited from class X and Y. That is why after A and B, it searches in class X and class Y, and again it searches in class Z. Then if it is not found in any of these classes, then it searches in object. So this is how the method resolution order will be defined based on the order of inheritance of the classes. So with this, we came to the end of the topic polymorphism of object-oriented programming. With this, we have completed the concepts of object-oriented programming, Module 11, and we meet again in the next lecture. Thank you.